All right, so with our 8.3a lesson, we're going to start getting to special right triangles. The first one we're going to talk about is what we call 45, 45, 90. I really like these. They're pretty simple. Once you get, the hang of everything going on. It starts off with a square. So facts we know about a square. We know that all sides and all angles are congruent, which means that all of our angles here will be 90 degrees. Okay, we have 4 90-degree angles. We're going to have diagonals, and we'll be drawing that diagonal in a moment. It's going to create 2 right isosceles triangles. So we draw this diagonal in. Let's say we draw a diagonal from segment BD, the best we can. We're going to wind up with 2 isosceles right triangles. Okay, we have 2 sides that are going to be congruent. So we're going to use this Pythagorean theorem to find the length of diagonal. We're going to find this formula. Okay, so since these 2 sides are going to be congruent, we could just call them both A rather than A and B. So when we use our Pythagorean theorem, knowing our longest side here is going to be C, we could say, okay, C squared equals A squared plus another A squared in this case with our 45, 45, 90. So we have C squared equals 2 times A squared. When we do the square root to get rid of the exponent with the C, what ends up happening here is we're going to wind up with C equals. The A is going to cancel with that radical, just like the C did. So we're going to wind up with an A. But the square root of 2 cannot simplify, and there's nothing to take away, so we leave that square root of 2. So our C, our hypotenuse here, will now become what we call A square root of 2. So there's several different ways of going about these problems. First, in a 45, 45, 90 triangle, the hypotenuse is the square root of 2 times as long as of each leg. Okay? And so what that means here is we're taking each leg, A, and multiply it by the square root of 2. That is it. So you're going to come up with some questions like example A here. They're going to be nice and easy. Okay? First thing I always suggest, label the sides with your A's and your A square root of 2. Here's A, here's A. How do I know? Because those are my 2 legs. And this is A square root of 2. That way you can look at what do I have and what do I set equal to each other. So here I see that I have A equals 5. Well, if A equals 5, we want to find, we already know what AB is. It's going to be 5 as well because they're congruent. So what we need to do is we need to take that, and I'm going to write this in with my erasable pen, but we're going to have A square root of 2. So with that A square root of 2, it's just your substitution property. I'm going to remove A, and if A equals 5, I'm just going to put the 5 there. Okay? So whenever you're given a number for one of your legs on a 45, 45, 90, all you're doing essentially is just throwing that number in front of the square root of 2 to get your hypotenuse. Okay? Next, we're given the hypotenuse. So let's take a look at what's going on here. I'm going to label my sides A square root of 2. So now I know that the A square root of 2 is going to equal 4. This is what I'm going to use to solve for A. So over here I set that up. A square root of 2 equals 4. Well, we need to get A by itself. So what do? I need to divide both sides by that square root of 2 so that these cancel and I'm left with A. Problem is we now have 4 over the square root of 2. And we learned we need to rationalize. We cannot have a radical on the bottom. How do we rationalize? Shove it and leave it. Multiply by that radical that's on the bottom, shove it to the top, and leave it on the bottom. So now as we go through, we simplified that. We're going to wind up with 4 square root of 2 over, well, the square root of 2 times the square root of 2 is the square root of 4, which essentially comes out to 2. And then we simplify these. 4 divided by 2. So A is going to equal 2 square root of 2. If you want to know a little trick about this guy right here, okay, a little secret. Only if your hypotenuse on a 45, 45, 90 is a whole number, you can actually take half of that and throw it in front of the square root of 2. And there's A. So here you take half of 4, which is 2, and slap on the square root of 2. And that will be your legs. Now, C, I'm going to help you set up a little bit, and then you're going to be left on your own with your with your, what you've learned with your radicals. So go ahead and star this one. I will set it up, and you will complete it on your own, ready to go over in class. First things first, let's label. Here are my legs. A square root of 2. Okay? So what we have here is, you know what, I'll go ahead and work this one out with you guys. All right? Yeah, this is a little bit different. You'll have one later just like this. So here we know what we need to set equal to each other. Okay? So we're going to go ahead and do that. A square root of 2 is equal to what? 3 square root of 15. So just like what we had to do with B. Now notice, B had a whole number. I showed you that trick. Now our hypotenuse does not have a whole number. You cannot do this little trick that I showed you of taking half and throwing on the square root of 2. Can't do that now. Okay? So now we have to actually work everything out. So exactly like what we did on B, we're going to divide both sides by the square root of 2. So these cancel. Divide by the square root of 2. And then we're going to have A equals, because these are gone, 3 square root of 15 on top, square root of 2 on bottom. As we know, we need to rationalize. No radical on the bottom. Shove it up to the top. Leave it on the bottom. So then we know that we can't do anything with the 3 because there's nothing to multiply it by other than this invisible 1. Square root of 15 times the square root of 2 is going to be the square root of 15 times 2 is 30. And then on bottom here we have that square root of 2 times the square root of 2, which is the square root of 4. And we all know the square root of 4, perfect square, is going to be 2. So there's your answer. And yeah, sometimes your answers will look weird like that. It's all right. The next one you will do on your own. Okay, no take-backs now. Here we have A square root of 2. So we know that A is going to equal 2 square root of 3. So we need to take this. We need to take the A, because I want to find C. We already know what CB is. It's the same thing. 2 as AB, 2 square root of 3. So we need to find this. So we have A square root of 2. We're going to remove, I'll go ahead and rewrite it. We're going to, again, I'm going to erase this A. I have erased a little pen. We're going to remove that A, and we're going to replace it with what we know A is, right here, 2 square root of 3. So now I want you to take this, your 2 square root of 3 times your square root of 2, and I want you to solve on your own. Next page, let's look at some word problems, some squares and stuff here. We have the length of a diagonal of the square is 8 square root of 2. So we're going to find the length of the side of the square. All right, let's draw this guy. Geometry, all about drawing. The diagonal here is going to be that 8 square root of 2. So before I do this, I'm going to go ahead and label A square root of 2. Okay, and all my sides are congruent. And then we also know that this diagonal is 8 square root of 2. So essentially what we're looking at is setting these two equal to each other. So we're going to have A square root of 2 is the hypotenuse with our formula, but it's also 8 square root of 2. So if they're the same thing, they're equal. So you are going to take it from here. Use any of the examples prior to this on the first page to help you out. B, you're going to do a lot of B on your own as well. Okay, let's take a look. The perimeter of a square. Ooh, changing it up there. So we have the perimeter of a square is 40 centimeters. Well, we know the perimeter is adding all 4 sides up together, and we know they're all the same. So 4 times A is going to give us that perimeter, 4 times each side. So we're going to find out that A is going to equal 10. So we have 10 on each side. All right. So we now also know that A is going to equal 10 because those are our legs. So we want to know the length of the diagonal. Again, this being A square root of 2. So once again, take what we've done before, okay, i.e. you could, example number 1, you can look at D and look at what we did. We did some substitution in there and solve for that. Example 3, ladies and gentlemen, you are on your own, okay? I showed you a way of actually working that out, and I also said a shortcut to whenever your hypotenuse is a whole number with 45, 45, 90. Now, with the example 4, I want you, this is going to be a little different here, I want you to find the length of LU, okay? SG and UG, we are going to find as a warm-up in class because that's going to bring us on to our next lesson. So here again, just as a reminder, here's a 45, so that means here's a 90. This has to be 45 also. So you're only looking at the 45, 45, 90 triangle here. That is it. Okay, ignore the other dude. We'll talk about him later. So we have congruent sides. I'm going to put this A on the inside. You'll see why later. And then this A over here, and then we know that the hypotenuse is A square root of 2. So you're going to find LU. It's a lot like example 3, so you can work it out, take that little shortcut, and then we will discuss the finding SG and UG in class as a warm-up.